So in this video, we're going to talk about how to solve absolute value inequalities by graphing. So solving absolute value inequalities by graphing is very similar to solving absolute value equations by graphing. So we're going to enter each side of the inequality as a function in Desmos and then look for the solution set. So here's what we're going to do. So remember that an absolute value inequality can be solved by rewriting it as a compound inequality. Remember that an absolute value inequality with a greater than or equal to sign will become an or inequality. An absolute value inequality with a less than or equal to sign will become an and inequality. So we can summarize this like this chart here, right? So anytime we see a less than or equal to, we know that our answer is going to be an and inequality. Anytime we have a greater than or equal to sign, we know that our answer is going to be an or inequality. So here's what we're going to do to solve absolute value inequalities. So as always, we're always going to start off by isolating the absolute value. Then you're going to look at the inequality sign to determine whether you have an or inequality. Then we're going to enter each side of the inequality as a separate function into Desmos, and then determine the solution set based on the intersection points of the graphs. Remember to use the inequality sign to help you determine your answer. So let's try solving this inequality by graphing. So usually we start off by isolating the absolute value, but you can see here that the absolute value is already isolated. So now let's look at the inequality sign. So based on this inequality sign, since I have a less than, I'm going to say this is going to be an and inequality. So what we're going to do now is we're going to enter each side of the inequality as a function in Desmos. So we're going to say this is y equals the absolute value of 2x plus 3 and y equals 5. So now I'm going to go to Desmos and I'm going to enter both of these equations into my calculator. So I have the absolute value of 2x plus 3, and then in row 2, I'm going to enter y equals 5. Okay, so when we graph this in Desmos, you can see that we have two intersection points, right? And whenever we're looking at the intersections, remember we're interested in the x coordinates. So the x coordinates will be -4 and 1. So remember, we had said that the solution is going to be an and inequality, right? So now when we think about these intersection points, you can think of them as being like endpoints. Okay, so this is a less than sign. So I should really have an open circle at both of these endpoints. Okay. And since it's an and inequality, my solution is going to be everything in between those two endpoints. So if you would rather, you can kind of sketch it out for yourself. So you have an open circle at both endpoints because of the less than sign. And this endpoint is going to be -4, and this endpoint is going to be 1. The reason I suggest sketching it out is because we're going to have to write this now as an inequality, right? So this is going to be -4 less than x less than 1. And we can also convert this to interval notation, which will be -4 with an open parentheses and 1 with an open parentheses. So, kind of sketching it out can help you when you're trying to write it in inequality and interval form. So now you can go ahead and pause the video and try doing this example on your own. So what I've done is I've went ahead and entered these both as separate functions into Desmos because my absolute value is already isolated in this problem. So I have y equals the absolute value of x minus 1 and y equals 3. So now let's look at the x coordinates of those intersection points. So we have intersections here at -2 and +4. And notice that this is a less than sign, so it's going to be an and inequality. And because it's a less than, I'm going to have open circles at both endpoints. So if I graph this out, it looks like this. I have -2 less than x less than 4, which is also represented by the interval from -2 to 4. And remember, I need open parentheses at both endpoints because they're not included. So now let's try this example. Well, this is one of those problems where my absolute value is not isolated, right? I have extra fluff that I need to get rid of to get that absolute value by itself. So how do I get rid of this +4? Well, remember, I need to use an inverse operation. So I'm going to actually subtract 4 from both sides. And so that's going to give me the absolute value of 2x minus 3 is greater than or equal to 9 minus 4, which is 5. So now I can work on solving this inequality. So the left side I'm going to enter as y equals the absolute value of 2x minus 3, and the right side I'm going to enter as y equals 5. So now let's go to Desmos and actually do that. So I have y equals the absolute value of 2x minus 3, And the second row, I have y equals 5. Okay, so now let's look at those two intersection points. So I have intersection points here at x equals -1 and x equals 4. So now we need to think about what kind of inequality we're going to have. So since we have a greater than or equal to sign, we know that we're going to have an or inequality. Also, we know that since we have greater than or equal to, we're going to have closed circles at both of our endpoints. And remember that for an or inequality, the solution set is going to go in opposite directions. So let me just sketch this out for you so you can see it a little bit better. So we have -1 and we have +4. So let's write this now as inequalities. So we have x is less than or equal to -1 or x is greater than or equal to 4. We can write this using interval notation with an open parentheses at -infinity and then going to -1, which gets a closed bracket. Remember for or we use the union symbol and then we have closed bracket at 4 and then that goes to +infinity. So we put another open parentheses at +infinity. So now let's try this example. So you can see here we have a lot of fluff around our absolute value that we need to get rid of, right? So we have this 3, we have this -6. So we need to work on isolating our absolute value first. Remember also when we have more than one term to do an inverse operation on, we do the adding or subtracting before we do the multiplying or dividing. So I'm going to start off by adding 6 to both sides. So when I add 6 to both sides, I get 3 times the absolute value of 2x minus 4 is greater than 12 plus 6, which is 18. Notice that my absolute value is still not isolated because I have this 3 here. So I'm going to go ahead and divide both sides by 3. And when I divide both sides by 3, I get the absolute value of 2x minus 4 is greater than 18 divided by 3, which is 6. So now that this absolute value is isolated on the left side of my equation, I can enter these both as separate functions into Desmos. So I have y equals the absolute value of 2x minus 4 and y equals 6. So now let's go ahead and go to Desmos and do that. So I'm going to enter my new functions. Y equals the absolute value of 2x minus 4 and y equals 6. All right, so now let's look at our intersection points. So notice we have two intersections at x equals -1 and x equals 5. So now we need to figure out what kind of inequality we have, right? So it's a greater than sign, so it's once again going to be an or inequality. And also because of the greater than sign, we're going to have open circles at both of our endpoints. So it's going to be open circles. And for the or, it's going to go in opposite directions, right? So it kind of looks like this. So from -1, we go this way, open circle at 5, and then this direction for the solution set. So when we write this as an inequality, we're going to say that x is less than -1 or x is greater than 5. When we write it as an interval, we're going to say it goes from -infinity, and in this case, -1 gets an open parentheses because it's not included. For the or, remember we use the union symbol, and then we have open parentheses at 5 because it's not included, and then it goes to +infinity. And remember, open parentheses at +infinity also. So now let's try this example. Let's solve for x. So we have 4 plus the absolute value of x plus 1 is less than or equal to 2. So notice that my absolute value has not been isolated. So I'm going to start off by subtracting 4 from both sides, right? Because this is a +4. So to move it away, I need to subtract 4 from both sides. So I have the absolute value of x plus 1 is less than or equal to -2. Okay, so you may remember from our solving inequalities special cases video what's going to happen here. But just in case you don't, let's go ahead and graph this. So we have y equals the absolute value of x plus 1 and y equals -2. Okay, so let's go ahead and enter this now and see what happens. So we have y equals the absolute value of x plus 1, and we have y equals -2. Well, look at these two graphs. They're never going to intersect, right? Because no matter how far out I scroll, you can see that this absolute value function is always going to be above 0, right? So it's going to be greater than or equal to 0, all the y values are, and this is y equals -2. So these two functions are actually never going to intersect. So that's how we know that this will have no solution. Okay, and if you remember, we said that in the special cases video because we said that it's not possible to have an absolute value that's less than a negative number, right? Because an absolute value is going to equal a non negative number, and there are no non negative numbers that are less than or equal to -2. So now you can go ahead and pause the video and try doing this example on your own. So I started this problem by going ahead and isolating the absolute value. So I started off by subtracting 3 from both sides, and then I divided both sides by 2. So that gave me the absolute value of x minus 4 is less than or equal to 3, which is an AND inequality. So I went ahead and entered this in Desmos as y equals the absolute value of x minus 4 and y equals 3. So notice that we have our two intersection points here at x equals 1 and x equals 7. So since it's an AND inequality, I'm going to look for the region that's in between these two endpoints. Also, since I have a less than or equal to, both of my endpoints are going to be included. So this is what that graph looks like. So it's going to be the interval from 1 to 7, and if I write that as an inequality, it's going to be 1 less than or equal to x less than or equal to 7. So remember, you can solve an absolute value inequality by graphing. Once the absolute value has been isolated, you can enter each side of the equation as a separate function in Desmos and look for the intersection points. The intersection points and the inequality sign will help you determine the solution set.